Somewhere tonight, in a kitchen in France, someone is going to order frog legs. They'll eat them without a second thought. It happens every single day, all over the world. Frog legs on a plate. Totally normal. But now picture the same plate. Same sauce. Same fork. Except this time, it's a toad on it. Nobody does that. Not once. Not anywhere on Earth. And here's the strange part. Frogs and toads look almost like cousins. Bumpy skin, big eyes, long back legs. To most people, they're basically the same animal with two different names. They are not the same animal. Not even close. One of them can put you in a hospital. One of them can stop your heart. Most people assume it's just about taste, or texture, or some old food tradition nobody questions anymore. That's not quite right. The real answer is written directly into the skin of the animal, and once you see it, you'll never look at a toad the same way again. So stick around, because by the end of this, you'll understand a defense system so effective that it's kept an entire species off every menu on the planet for thousands of years. Let's start with the frog, because the frog is the trickier one to understand. You'd think a soft, defenseless little animal with no claws, no teeth, and no speed would be an easy meal for anything that wanted to eat it. And a lot of the time it is. But frogs are not as helpless as they look. Almost every frog on Earth has poison glands built into its skin, not just in one spot, everywhere. Across the back, down the legs, all the way to the tips of the toes. Scientists call it a full-body chemical shield. Here's the twist though. In most common frog species, that shield is weak, mild, barely noticeable to a human. It's not built to kill a predator. It's built to taste absolutely disgusting. Bitter enough that a bird or a snake bites down once, gags, and lets go. That's the frog's whole strategy. Be gross enough to spit out, not dangerous enough to matter. Which is exactly why humans have been eating frog legs for centuries without a single problem. The mild toxins mostly sit in the skin. Skin the legs, cook the meat, and the danger is gone before it ever reaches your plate. Now here's where the story flips. Toads did not go down that path. Toads went in a completely different direction, and it might be the strangest part of all. Instead of spreading a weak defense evenly across their whole body, toads concentrated everything into two glands, sitting right behind their eyes. Scientists call them parotoid glands. Think of them as two tiny chemical factories built into the toad's skull. When a predator grabs a toad, those glands don't just leak a little bad-tasting slime. They release a thick, milky white foam. And that foam is not there to be unpleasant. It's there to fight back. Inside that foam is a compound with a name that sounds almost too on the nose. Bufotoxin. Bufotoxin belongs to a family of chemicals called cardiac glycosides. That might sound technical, so here's what it actually means for you. These are the same class of compounds found in certain heart medications. Ones doctors prescribe in tiny, carefully measured doses to control a struggling heart. A toad carries that kind of chemistry in its skin, untested, unmeasured, and built for a predator's body, not a controlled dose. Swallow enough of it and it doesn't just upset your stomach. It goes straight for your heart. It can throw off your heartbeat, send your nervous system into chaos, and in high enough amounts, stop your heart completely. Imagine you're a fox or a dog or some other animal that's never met a toad before. You clamp down out of instinct. Within seconds, your mouth is burning, your eyes are watering, and your body already knows something is deeply wrong. Most animals let go instantly. The ones that don't always survive the lesson. So what killed it as a food source before it ever had a chance? It wasn't decided by a chef or a culture or a recipe book somewhere. It was decided by evolution, millions of years before humans ever lit a cooking fire. And it's not just the common toad doing this. Species like the cane toad take it even further, carrying toxins strong enough to kill dogs, and in rare cases, even people, just from a bite or a lick. But here's what's fascinating. Frogs and toads didn't choose these strategies at random. Every predator that ever tried to eat one acted like a filter. The frogs that tasted merely unpleasant survived just fine, spitting out of a hungry mouth. But any toad relying on that same weak trick eventually got eaten anyway. Only the ones with something stronger, something that actually punished the predator, lived long enough to pass on that trait. Generation after generation, that filter kept sorting. Weak defense, gone. Strong defense, survives. Repeat that for a few million years and you end up with exactly what we have today. Frogs with a taste that says, don't bother. Toads with a chemical weapon that says, you'll regret this. Compare that to something in your own life. Think about the last time you touched a stove that was hot but not hot enough to burn you badly. You probably touched it again eventually, more carefully. Now think about the last time something actually hurt you badly enough to leave a mark. You never went near it the same way again. That's the difference between a frog and a toad, played out over millions of years instead of one afternoon. And humans figured this out the same way every other predator did. The hard way, passed down as warnings. Long before anyone understood bufotoxin or cardiac glycosides, people simply knew, generation after generation, that toads made you sick and frogs did not. That knowledge became tradition. Tradition became cuisine. And somewhere along the way, frog legs ended up in fine dining, while toads never got so much as a folk recipe. There's one more twist to all of this, though, and it's the part that really changes how you should think about it. That same toxin that can stop a predator's heart, scientists have been studying it for something else entirely. Some of the compounds related to bufotoxin are being researched for their effects on the human heart and nervous system, the same way other deadly natural toxins have quietly become the basis of real medicine. The line between poison and medicine isn't as clean as we like to think. It's almost always just a question of dose. So the next time you see a frog and a toad sitting side by side, remember this. They look like variations on the same idea. But one of them bet its survival on being merely unpleasant, and the other bet everything on becoming something you'd never risk touching twice. You've spent your whole life sorting the world into safe and unsafe, edible and inedible, without ever really asking why. Most of those lines were never drawn by you at all. They were drawn millions of years ago by every creature that made the mistake first so that you never would have to.